All right, I'm doing a pretty quick, short lightning talk, and it's going to be a little bit about what we're building here at Union, but mostly about our open source. So, do people like open source? Earlier, Jim asked how many people heard of Flyte. It wasn't that many, but I'm going to ask again. How many people have heard of Flyte? Flyte. But now we know it's a lie because you heard about it when Jim mentioned it. So the hand should be more by now. But I'm going to talk a little bit about that. And it ties into building durable AI pipelines and now agents as well. So people are building agents in the crowd. So hopefully this will be interesting to you. A quick introduction. My name is Sage Elliott. I'm an AI engineer here. You can find me on LinkedIn. Look up Sage Elliott or scan this QR code. But I should pop up if you just look up for me there. Also, I'll note this again, but we are hiring as well. So who's looking for a job? Who else is hiring? So everyone who raised their hands looking for a job should find these people and talk to them afterwards too. People are giving thumbs up. So Flyte has been widely adopted to build durable AI pipelines since I think it became actually open source in 2020, if I'm not mistaken. But it started originally inside Lyft. That's why it's spelled with a Y. That might make more sense to people now. Everyone's like, oh, that's how that Y came around in there. And I can almost guarantee that every single person in here has interacted with a model trained on Flyte, whether that you're using like a foundational LLM. Who's used one of those? Probably every single person in here, right? It would be weird if you hadn't at this point. Social media, listening to music, so we have like Spotify, a lot of self-driving car customers. We have a lot of overlap with people that use Voxel 51. If you haven't looked at them yet, I'm sure you'll hear more about it at Dan's talk. But we have a lot of crossover customers that use this in that space. And then pretty much anywhere else you can think about machine learning. But orchestration, so like what we are is an AI orchestration platform or AI orchestration and inference platform. So we help manage compute between different pipelines and artifacts. So like you're like, I want however many CPUs, I want this GPU, I want this much memory, I want to spin up, do this task, I want to handle caching between these other tasks. We make that really easy in a Python SDK. This is what V1 has been about. So how do we design for the next decade and build more durable dynamic runtime? So almost everyone here raised their hands about building agents, I think, right? A lot of people are starting to build agents in V1. They wanted more dynamic runtimes. Previously in V1, it got compiled into a DAG, so you'd have like this kind of static workflow that you could do some dynamic stuff in, but it wasn't quite dynamic enough for everyone. So we're introducing Flyte 2.0, which I think everyone's going to be really, really excited about. It brings pure Python, so there's no more domain-specific language. It doesn't have to go into a workflow, get compiled into a DAG. It fans out, so you can just program in async IO. Has anyone used async IO yet in Python? Quite a few people. It's awesome. You should be using it or look into using it if you haven't already. But you can just program it like that, and it'll automatically spin up different containers, and I'll show a little bit what the code looks like there. So now that it's pure Python, you can try catch. You can run any dynamic thing, including agents in there. And as a built-in image builder, so you also don't have to worry about Docker containers and doing isolated containers between different coding agents. And it still runs on Kubernetes. So Flyte is always tied to Kubernetes. It could be on cloud, so a lot of people use AWS, GCP, or it can be on-prem. So really, where there's a Kubernetes cluster, you can deploy Flyte to manage it. And just kind of a multi-agent example here of what it looks like in 2.0. So this is available today actually on Union in beta. So if you want to test it out, you can fill out a form, test it out for free, give us feedback. We're looking for that. And then the full open source is coming out soon, which I'll probably mention again. But again, this is compute aware, and I'll show what that looks like in the code. Everything's versioned, so every time your agent does a run, or you're building a pipeline like training a computer vision model, that you get a whole snapshot of this. You get the inputs and outputs between all those different tasks, always logged there. You can have reports, which is showing here, which can be any HTML or Markdown that gets embedded, and again, versioned. So I use this a lot to like prettify my outputs kind of and have like a report of what's going on. You get metrics like what compute was used. Task info, again, basically think of a snapshot for your whole pipeline, including your code as well. We actually added a code tab, so in the platform you can click in and see the code that like your coworkers are deploying to if you want to go peek at it. You can also pull anything down to the UI with a remote SDK. So again, really accessible. So what does it look like? So here's a little snippet of the code. Everything basically starts with building an environment. So every task, which I'll talk about next, runs inside of an environment like a Docker container. Who loves writing Docker files? One person, but I don't know if that's true. 2 people. Well, you don't have to use this then. But literally no other hands went up. So what you do in Flyte is you can just declare a task environment, and then you say what like base of Linux you want. You can pass in different like a requirements.txt or use UV. So you can actually use UV scripts, which is really cool too. You can pass in secrets, so all your secrets can be managed in Flyte as well. And you can say like what the key is and then how you want to read into the environment. And then this is the compute aware piece. So you're just saying 2 CPUs here, 2 gigabytes memory, and 1 GPU. And then you can change this. You can assign different specific GPUs as well. So if you like A100s and T4s, you can assign those as well. And then we also have a reuse policy, so you can spin up a certain amount of replicas and then say how much concurrency you want and like what the scale down looks like. So really easy to declare an environment that you can spin up reproducibly over and over in your pipeline or that your agents can run in. And then a task is like that unit of execution. So this could be, a lot of times for agents, I build like multi-agent systems, and each agent will often be a task in this case. And it's an async Python function. And you're basically just, we do enforce strong typing. Who likes strong typing in Python? Great, way more than I thought. Times are changing. I feel like I asked this question like a year ago or 2, and not as many people raised their hands. So we enforce strong typing, which a lot of people actually do like. And then everything's containerized. So we saw like what that container looked like every time you run an agent or a task. It spins up in there by default, unless you use that reuse policy. Then you can reuse that container between tasks. You can run other tasks. So previously in Flyte 1, you had a workflow decorator, not just a task decorator, and that's where you got that compiled DAG. Now you can just do it fully dynamic in a task. Everything is serialized. All the input output that you kind of saw in the UI there, that's all serialized between tasks as well. It's observable. You saw that you can click in, get the logs, the input output, the environment, who ran it, et cetera. All in the UI, but again, also you can pull that down in the SDK. And yeah, you just, again, we declared an environment here. That's where that variable came from. Then we just say @env.task, really easy, reproducible environment. And then we also have traces. So if you don't need a whole task, you can just add flyte.trace on top. And this gives you in the UI, here's this little dot here, we get the input and output, and you still get retries, which I'll talk about too. But this doesn't run in a separate container. So if you're doing like a multi-agent workflow and you're doing a tool call from there, you might want to have a trace in here. So if it does fail, like an API times out, you get retries, and you also get tracing in the UI, but you don't have a whole separate container that spins up for it. But how can we add more durability? So I already talked about kind of retries. Out of the box, this is something that was in Flyte v1 as well, where if you have a failure, like a rate limit or an API failure, you can gracefully recover, like by default, it'll just retry and spin that up another time 3 times. But you can override that, so you could say 5 if you're dealing with a weird API that you think is going to fail a lot. One cool thing for agents is like if you're doing costly reasoning or something at the beginning, and you spend a lot of tokens and time, and then an API fails out later, you don't have to do that if you do like a retry and it recovers from it. Error handling and dynamic recovery. This is, I think, really exciting. We're going to see some interesting stuff around this. So you can adjust your infrastructure here based on the errors that you're getting in Flyte. So in here, it does an out of memory error. You can see that at 250 megabytes and then it overwrote itself to be 1 gigabyte. And what that looks like kind of in the code, in this case, is you're saying if there's an out of memory error with an except, rewrite the infrastructure with these resources now. So you could have different loops and you could have agents basically actually understand why their infrastructure is failing and then rewrite their infrastructure to succeed, which is really interesting. Also, who thinks this looks kind of easy to write? Like to add? You're adding a couple decorators, you're doing this. 1 person, 3 people, 5 people. Okay, more people raising their hand. If it's easy for you to write, do you think it's easy for AI to write? No? This is, I will say, so like if you just have a couple examples, like give it the right context, like have 1 example or something like that, Claude does like an amazing job just rewriting like now production grade things, because you can have like, hey, write an agent or write a pipeline, here's how to do it, and then you have basically a production grade infrastructure right away. So we also have an MCP server that's in beta right now, and it does a really good job. You can just say, write any type of pipeline, and it knows that it should write it this way, and it just goes and does it, and you get that whole durable infrastructure right off the bat, which is really exciting. Some other features, I probably won't list all these. I think I talked about most of them. Caching, reports, traces, kind of all the stuff you'd expect out of a durable pipeline transfers over to the agentic space. It's just now this is really fast and dynamic. Caching, by the way, is really good, even if you're using it locally, for debugging agents. So if you're also working on like a long agent flow, and then you don't want to rerun the entire thing to like work on that last task, adding caching is great for that. What else did I want to say? Oh, we just added human in the loop, which is really exciting for us. I'm going to build some examples on that soon as well. Just released in the SDK this week in the beta of, I think, 5.56. It's not even in the docs yet, is a text user interface. Has everyone heard the term 2E before? Yeah. If not, that's what it stands for. And so now, right in the SDK, even if you don't have like a cluster that you're connected to, you get this kind of the 2E version of that interface that you saw that I was showing. But this runs locally in your terminal. And this is really easy and helpful to also debug like your agent and pipeline runs. So you get this visual representation. You can see when they fail, or if they succeed, and then you can click in. It'll also have the inputs and outputs log there, which is cool. So this is just in the SDK without any cluster. If you just want to like install this and kind of get this out of the bat, you can also do the reports. I don't show it in here, but I show the reports embedded in the GUI. That's also here. So they'll save an HTML report locally for you, and you can look at that, which is cool. We also do app serving, so I talked about pipelines and tasks, but if you kind of like that infrastructure piece and like how the Python SDK is laid out, you can also serve apps. So if you're doing like Gradio or Streamlit or serving models, you can just kind of do that compute-aware infrastructure piece with it. So you can try it today. There's a QR code. You can also just go to Union.ai/beta, and it might also be the kind of banner on there right now. The SDK is available in open source today as well. If you want to try what you saw today, sign up for the beta of it running on Union. And then the full open source general availability is planned for, I think, late Q1 of this year. So if you liked what you saw, hopefully you'll be excited when we do the full release. But if you want to try it out, give us feedback, sign up for the beta, or try out the SDK. Now, who's heard of Flyte? I think everyone. That's my talk.